Hello, how are you? Welcome to a new class. In this opportunity, we are going to inspect a little the issue of the configuration file environment. As we were already working in local environment of Docker Desktop at localhost level, we saw that what we were doing is first a copy of the file, nvev that brings the repo, let's say. This file, we're going to open here in a tab. This file is the one that parameterizes everything, the operation of the stack in terms of the variables with which the stack lifts, right? I'm going to open then the Docker Compose, desktop, and the N file, and we are going to begin to correlate the environment variables that are neither more nor less than the variables with which I configure the behavior of each one of the services. For example, the Django application needs these environment variables to operate, is not it? For example, it needs to know where asterisk is in terms of networking, say where to locate asterisks, because we know that the application uses asterisk manager interface, AUSN to connect. To asterisk, it needs to locate it in terms of hostname resolution and also use 1Password to connect to AMI to perform actions. Also, the Django application needs to connect to its database backend, which is Postgres. Therefore, it's going to need a number of parameters as just the location of Postgres, the host name, but also the name of the database that uses the application, the port, the user, the password, if we are facing a database instance that is deployed in high availability. In that case, you can also make a split, let's say, and pass usend, the address of the read-only Postgres versus the read-write Postgres. I mean, there are several parameters. The application uses Redis, the application uses WebSockets, and a whole host of necessary parameters that the Django Omnilit application is going to be governed by to operate. We're going to have, well, then the part of channels, crons. Yes, which are components that interact with each other, conforming our instance, isn't it? We were just talking about this one. We saw that it was channels. So we saw that it was a service called Chrome. For example, FastAGI, for instance. We see it here as a component used by Asterisk to outsource, let's say, all the execution of the dial plan AGIs. Then FastAGI, among other things, will interact with Redis and will interact with Postgres, for example. So, if you notice, all these variables, many of them are repeated. For example, the AMI we see that is used by FastAlg, but it is also used by the application AMI as environment variables. It will also be used by asterisk just to set the user and password that will be used by this asterisk at the AMI level. Therefore, each of these components tells somewhere of the component service declaration with which environment variables needs to operate. This is asterisk, another of Omniliad's core components. Asterisk is going to need to connect. Asterisk needs to leave in the bucket, in the object storage, the recordings. Asterisk, if you are going to use Homer to send you reports of all your SIP and RTP activity, you will also need to know where that Homer is if it is enabled. That Homer if is enabled, and then that Homer, host, and port to make the connection. Same for all. Camilio needs to know where Asterisk is, because Camilio is a WebRTC bridge together with Asterisk's RTP engine. Then Camilio also uses Redis to let register of the agents that register through WebSocket zip. And so all the components, in Nginx, for example, Nginx, we saw that is a crucial component because basically takes care to receive all the web requests and act as a reverse proxy, then routes the requests according to the path that comes explicitly in the request. Then, from now on, Nginx is going to need as a component, say once deployed in production, to know the host name of these other components to which that redirects the requests. Well, then it's obvious that Nginx is going to need, where is Django? Where is Daphne? Where is Camilio? And where are WebSockets? Wise? When you add those three, or even those four components, it just makes the redirect of the request according to the path. Additionally, Nginx is going to route some specific requests that have to do with requests to files of the media type that are stored in Minio or within the object storage. That's also why it's here receives as an argument the S endpoint, which is essentially the URL where the object storage is located. And so we can going through each one of the components according to its greater or lesser complexity. It will to have more interaction points, more environment variables with respect to the other components. But it is very important to get clean that the base functional of all this USIND is from a component that is materialized as a container. And that invokes the image, and this image put into a container, put into place, so to speak, requires a number of environment variables. Now, this environment variable, which we declare them explicitly in each component, we see that many allude to $braces and the name of a variable in uppercase. And this relationship is what we have to do now, which is that this variable, which is the variable, when we talk about variable, not constant declared directly, as it usually is here in the same Docker Compose, the port number. There are some environment variables that are directly the string or the number declared here, but most we will encounter this, the $, braces, and the name of a variable in uppercase. These variables reside in the file. If there is a control F, for example, and I look at all AMI user, AMI password, asterisk hostname, the hostname of all the components. Yes, because, well, going back to the architecture thing, asterisk has to be able to find Fasagi. Asterisk also needs to find and connect to Nginx to reach WebSockets and set up the socket for provisioning the configuration. Needs to insert all call logs in POR, and so on. Chrome needs to extract SQL reports from PostgreSQL and insert them into Redis so that the real-time views look up those results in Redis. Also, whoever hosts the real-time views, which is Django, will need to connect to Redis. And so all the components are chained together. Most of them are of minimal importance. We need, for instance, the host name, Django needs to know where it is located. We said, for example, asterisk, then there will be an asterisk host name around here. Then we have users of AMI, users' names of databases. We saw that several components require, for instance, the VG host. If this variable, which is nothing more or less than the host name, where it is, serving the connections. We also have the database name or the password or the port. Well, all are parameters that are in this file. Env of environment. The default file comes functional to the Docker Compose. Desktop if. Therefore, if one, as we saw, the first classes directly in the desktop environment, we simply we would make a copy of the N file. We would make a copy of the N file already. We would simply make Docker Compose app and we would have the environment up. Because, I repeat, the Docker of Compose YAML by default for desktop for localhost already comes, or rather length, this comes set to work in desktop mode. When we involve the use of first boot installer sh and run the installation script on an instance in LAN or cloud, but in an instance that already serves connections in a productive format. We see that well. Himself does several things like installing Docker, how to clone the repository, how to generate the copy of the environment, and then take care to edit that environment file according to the deployment that we are going to use. In our case, what we have here, productive, isn't, in this architecture, the simplest, that is to say, the hosted instance, and all the components contained within the Linux server that is officiating as host of the containers is not it. Therefore, we are going to see that there is here also the documentation warns of what minimum aspect is going to have are some parameters, some variables of the environment. If I go to exactly now, here in the deployed instance, I have the environment that is the one that brings me the repository. But to see the hidden ones, there is also the point environment that the installer itself generated me. If I open it to the point environment, now I see that the thing differs to the original file. That, for example, in environment says usend, and in public IP has nothing. Versus, to me, I see that my point environment generated by the installation script first bound installer puts me here that is cloud and puts me here a public IP address. Another change I'm going to start seeing is in the host name. Let's look at the host name Django, host name localhost, Daphne, which is the asynchronous part of Django localhost. I'm going to look at the asterisk host, which I have on the asterisk host, the IP private associated with the NIC that I instantiated in the installation. In this NIC, I see that using this is 10.10.6, the private IP of my Linux host, and it is the one that asterisk takes. Also 1006. Postgres localhost, WebSocket localhost, and so almost all localhost Camilio, or rather, well, Nginx, this is the address that will take Nginx 10.10.6. Engine 1016, the private IP Redis localhost. Well, let's see that the different components now were affected precisely by the Fairpute installer, which, as we saw here we have it. Just it is in charge of change. Change with set. Change from BEM to the environment that we have passed as argument. Change the Django hostname from app to change the parameter public IP from to be empty to contain the public IP that the script detected on this line to asterisks. 2 is, which should be around here, set the private IP. Here we have it. For example, yes. And what does this have to do with the fact that in this distribution where we have our stack Docker Compose, we need to ensure everything integrates smoothly. We are going to have these two components, especially that perform a treatment with audio. Let's say treat the audio of the calls on one side. On the people side, it is WebRTC, let's say. Using for audio exchange. But the thing is that both he and he use a range, use zip. And as we well know, zip is a signaling that goes to out of the bank or signal media sessions that then that media ends up streaming over a range of ports. And this, with the world of containerization, is quite a clash. If these real-time applications that implement zip and the topic of containers is a little complex issue, precisely because all this topic of the range of ports outside of the signaling complicates things a bit. One cannot do a port mapping directly, expose the container ports, 10,000 ports, because, well, whoever does the test is going to see that that translates into a high load for the host that has to maintain that rule. So what we do is we pull up the application in Docker, but using the networking host mode. That networking mode that is used for when you have to put the application, expose it, whether it's on a LAN or on a WAN. Implied, as you'll see here, that the difference between a Docker Compose YAML that we use for local environment has a network. A network declares a network using the default networking mode, the default driver of Docker networking. So, well, without going too deep into it, you can read about it. It is very widespread as it is the Docker networking, but is a bridge type network where there is a NAT layer in between. So this in local environment does not affect, but in a productive environment. Productive, as we said, already, which implies loading the system with many calls and with several ports making audio streams in the high UDP ranges, these 40,000 to 50,000, it is necessary to use another network configuration, which is host mode. What does the host mode do? Directly allows us to see each component of these. Very similar to the way we saw the components in 1X, that is to say, are in the space of network by default. That is why we see that the container suddenly fast when it needs to connect to Postgres, it does it directly declaring to localhost. And also we see that so much asterisks as RTP engine, as Nginx, have as hostname an IP address, the IP address private of the Linux machine. Why? Because they are the three components that take contact with the outside world. If they are the three that take contact with the outside world, and that is why they raise here the IP private of the host, while the rest of the components expose their service on localhost, that is Redis, opens the port 6369. On localhost, Postgres opens the 5432 on localhost. the same, that we can easily see if I do. For example, if I am here and I do a netstat, it seems like it is not installed. Well, this is the way that I have memorized how to list the ports. Open. There are several and better, but well, this is a way that will tell me, look, for example, the port of Kamailio WebSockets is in 1,27,001. The port of Redis, 1,27,001. The port of, this is Django. This is channels, if I remember correctly. Daphne, over here we have Postgres. This is a question of, also, to be quite zealous, of the ports that are exposed on the host. This for a question of security. While that, out there we see the asterisks on the 10.10.6, and we are going to see on Jinx the 443. Where is the 443? Here, that is directly open to the world, since it is there where the connections are received. If we look to see the UDP part, if I remember how to list USEND. Let's look at UDP. 5060, open to the internet. Then we have the cloud firewall that allows in that 5060 to filter, but in a cloud firewall layer. So, well, wanted us to consider this issue of the point environment for environments that are already of productive nature, as we were seeing, that materialize from the first boot installer. And we see how well this changes and what is the sense of these changes. It is important to note that the stack is working with the network in host mode. That's why I can easily from Redis raise the container by making listen on localhost, because it's going to be using the 1,27,001 from the host, SUSE of the Linux host. Well, here we also have all the application parameterization. If I want to rotate the Postgres password, I want to change the asterisk Amy passwords, which is where, back from where Django logs into the asterisk manager interface. I have the passwords to access to the object storage, Minio. These are all parameters that, well, one can start modifying. If I wanted to add, well, change the passwords with which they authenticate to Wombat, Dieter, and so on. Here one comes change parameters, and then we simply do a Docker compose. F and the YAML that we are using. D, and this goes to 2009. In case we detect a change, recreate, relaunch the containers involved in that variable, let's say, that affected by the variable that we changed, and the stack goes back up with the changed variables. It is very important as to go concluding then to understand that the fruit of this file, or this file is fruit of the first boot installer that made the copy and that also parameterized it with set USEND to leave it in production mode, to leave it in Docker network in host mode. And, well, from there also pull out and go, unraveling a bit this relationship between the environment variables that are necessary for each component to be launched as a container from the Docker image, from the image, and well, that these variables reside in the environment file. I hope that I have shed some light on this topic so that we can, well, continue working with our current stack.